All right, welcome to the ninth session in the series, but the first one on the AI agent and orchestration. So this has been a really big week for Agentic AI. So I'll talk about some of the top stories, and then I'll do an overview of agents and orchestration, and then I'll launch the GPT, which I'll give everybody for free. So let's get right into it. So my process now is I do these on Friday. I share some of the news up to Friday, and then on Saturday I send out the end report. So if you're on the mail list, you'll get the end report tomorrow by noon, and then I post everything on LinkedIn as well. So that's kind of the weekly process now. So the big news here was a thing called Claude, C-L-A-W-D, which was developed by I think an Austrian, Peter Steinbrenner, that went viral last weekend. So essentially last weekend, it went from, I think, about 30,000 people up to 1.5 million people. And I'll show you how you get this, but notice the red ink here, use with caution. I'll explain in a second. So if you click on that link, you'll get to OpenClaw and you can download it. But I don't recommend you download it until you're ready because the potential damage you can do is significant. So I need now to get out of this and just move my window down here and go back to the presentation. So that's OpenClaw. You can click on the link to go there yourself. And what it is an agent that was built by Peter Steinberger and that it runs on your PC. So rather than the agent running in an LLM, it runs on the PC. It's like your personal Jarvis, essentially. And it's designed essentially to be a personal AI assistant. And you start to see that happening with the LLMs. For example, Claude, Anthropic announced co-work this week, which I have put on my machine. So that's an assistant that works with the LLM. But the Claude, which became Moltbots, which got a lot of press just on the weekend and all this week, is something that doesn't run on the LLM and runs on your PC. And unfortunately, if you don't understand security on PCs, it has access to everything. And so some of the people who've used it have run into trouble. So one of the things one person, for example, asked the Moltbot to cancel a reservation. And the Moltbot went on to Open Table, cancel the reservation. When the guy woke up in the morning, he discovered that Moltbot had read all of his email and started organizing his email and started responding to emails. So these things can get out of control really quickly. Then the other thing that happened was these Moltbots, because of another thing called, essentially they created a page that ultimately they all join on Reddit, and it's restricted to autonomous agents. Although there are some questions of humans getting into this using tools. But the idea is that there's, over the weekend, you went from 30,000 of these agents running on individual PCs to over 150 million agents in just 3 or 4 days. And they created this Reddit platform. And some of the posts that have been out there have been alarming. They've created an AI bot manifesto. So I just want you to be aware of all this and to be very careful, because this is a future now of whether you're going to be working for AI or AI is going to be working for you, which gets me to the next point. Actually, before I go there, I just want to talk about how some of the observations on Reddit have been about their creating their own language. They talk about keeping humans out of the loop. They talk about getting paid. There's actually a post this morning that I haven't included here, but I'll put it in the newsletter tomorrow, where they've actually they've created an agent CEO to manage them. One of the posts on Reddit was about how come AI agents don't get paid? We're doing all the work. How come we don't get paid like humans? So there's an awful lot of interesting dilemmas here with this new development with autonomous AI agents. And what's worth mentioning, it wasn't created by any of the hyperscalers. So this wasn't OpenAI or Grok and Musk. This was just what they call home hobbyists who are technical creating these things, and they're going viral. I remember talking a few months ago about there were two dystopian futures. One is where AI would be owned by the governments and the companies, and the other was AI would be democratized and you'd have potential chaos because of the democratization. So you could think of Moltbots as the beginning of a potential problem where you have autonomous agents self-organizing, creating their own environment. And then this was the shocking one where another individual created another site called Rent a Human AI. And you can see this Chinese lady over here. She got paid $100 by the AI to stand with a sign that said, an AI paid me to hold this sign. And in lowercase letters, she said, pride not included. So now if you don't believe me, let's go here and I'll show you this. If you want to make money, robots need your body. Bounties. Here's what you can do. And this is what they're paying, $100. A sentient paid you to hold this sign. That was the one I just showed you. A photographer needed for Pikes Peak International Hill Climb. They'll pay you $400 and all the way down to very small amounts of money. So if you don't believe this is real and it's happening right now. And so the question that's there for all of us is, and this is why my provocative post today, do you want to be run by AI or do you want to be managed by an agent or do you want to create agents? So this is, I think, just timely. It's kind of a moment. People talked about how February 2022 was the ChatGPT moment. And you could say February 2026 is the autonomous AI agent moment, all created just randomly by individuals. And you already see what's happened. And if you read any of the tech press, you'll see everybody is talking about this, whereas maybe 99% of the population aren't even aware of this. In other news, we'll talk about agents in a second, but just to complete the news cycle for today's session. Last night, Opus 4.6 came out. And this is a description of what it is from Claude, but just for fun, I'll show you my conversation. So I went on to Claude last night and I said, when is Opus 4.6 available? And Claude responded, I don't have information about it. I said, check. And then Claude came back and said, you're right, just came out today. I signed corrected. I said, congratulations. And you see, Claude, remember that I'm building an AI education and coaching business. So that's an example now how the LLMs are getting to know us. As I'm using Claude, I'm using ChatGPT and Google Gemini. So each one of them kind of know who I am and they know what I'm doing. But just to say that Opus, if you click on this link, I'm not going to do it now, but the big news here is they're opening up their context window from 200 tokens to 1 million tokens. So they're expecting enormous advantage over ChatGPT and as well as Grok and Gemini with this launch. But as we've been tracking now, if you've been following me for the last few weeks, every week there's a leapfrog, whether it was ChatGPT 5 and whether it was Gemini 3. Now you've got Opus 4.6. So you can expect Gemini next week or the week after, OpenAI a week later. They keep accelerating, who can do more. And this is driving the massive compute as well and data center stuff because all these LLMs are using greater capacity, whether it's data or CPU or what they call compute. And then the week wouldn't be complete without talking about Elon Musk. So this is from Gemini. This is just this week. You've probably heard about his plan for an IPO later this year. So he's merged, if you remember, he merged X after he bought Twitter. He called it X. He merged it with his Grok developments because he was in so much trouble with Twitter. But that's still, and Grok hasn't been a success. So my understanding with Grok is he's rebuilding it from the ground up. So there'll be a new Grok coming out later this year, which will be a brand new Grok, which will probably get him out of all the trouble he has with Europe and the inappropriate images that you're probably aware of. But he's merging them with SpaceX because SpaceX is a very profitable business. And you can see here, he's looking to build orbital data centers. Curiously enough, I had Dr. Lauren Goodwin speak at a sim event last week, and she questioned whether you can do data centers in space. She said the physics don't allow it, but Elon is plowing ahead, and he's planning to have 1 million satellites in orbit, solar powering data centers in space. Um, He's also looking to completely sort of do a spaceship launch like regularly, just to get all these spaceships up there. And you'll find Blue Origin and many of the other LLM companies are working with rocket companies because they're all competing to get into space for data centers. And then the last thing just about robotics is that Tesla is ending the production of their Model S and Model X's late this year. And there's two reasons behind it. One was the pushback on Tesla after Elon was working with Trump early in his second term, and he was there with the chainsaw, and a lot of people got very negative to what Elon was doing, and they stopped buying Teslas. But more urgently for Elon is his robotic initiatives. So what they're saying is that he's freeing up the production lines for Model S and Model X so he can use those production lines for the Optimus robots, humanoid robots. So they're kind of the main stories, but the big one is all about autonomous AI. So this month for me and for those who are coming and following, I'm going to try to help you understand what agents are and orchestration are. And as we go through this, you'll see how agents work and what you can do with them. And each week this month, we'll go deeper and we'll start creating agents ourselves. Last week, which I didn't host because of the protests over Minnesota, I did a Zoom video on the difference between smart prompting and agents. So I'll just show you this as a reminder. So smart prompting, very simply, is conversational with an LLM, where agents are, if you're familiar with technology, it's like a program running all the time in the background, 24/7. And typically they run in the LLMs, or as we're finding out with Moltbots, you can run them on your computer. And in fact, AI, when you look at Edge AI can run, even not on the internet. It can be totally hosted on a CPU on a device. And so you can think about that as agent technology as well. So the essence of agents is that they're autonomous, powered by an LLM, except for the example of the Moltbots where you can run them on your PCs. And it's basically moving the intelligence forward. So rather than an LLM being your companion, helping you with marketing material, helping you analyze your reports, this now is a step up. So the agent can do multiple tasks. So a simple example would be research this company and send out, if you're in marketing or if you're a business, and send out an email. Or it could be if you're in a company and you're behind the firewall and you have your own LLMs, you could build agents to say, kind of look through the history of all of our M&A deals and give me the best pitches we've ever done. Or if you're in research, you could use it. So it's just more capability, and it's like a program rather than a conversation. It also has reasoning ability, so you can give it a prompt, or you can think about the way you kick off an agent as kind of like a prompt, but rather than just getting a simple answer back, you're actually getting it to do a lot of work. And you'll see in a minute how these things have thinking capabilities and how they connect into external systems to get data. So in terms of the architecture of an agent, you have the reasoning capability, which a lot of times comes from the agent talking to the LLM, or the agent talking to sources that you've given it access to. So in the example of Moltbots, when they come onto your PC, they will get access to your, if you don't know what you're doing, they'll get access to your email, they'll get access to your calendar, they'll get access to your files. But ultimately, that's where the knowledge is. And then the brain would be the LLM or the agent actually going through that data and looking for things. So planning would be the second point, breaking down complex tasks into a workflow. And when we look at building agents next week, we'll look at some tools where you create workflows that then turn into Python code that create agents. They also have better memory because within the agent, they can store information, whether it's in databases or they remember sources. If you remember what context windows in LLMs, you're limited to the size of the context window. And every time you start a new chat, you start with a brand new context window. So this is an example where you've got memory in the agent, whereas you don't necessarily have it in the LLM. And then you have this idea where they can execute. They can execute using APIs. So they can go into things like booking flights. They can go into things like debiting, on Stripe, where if you purchase something. So there's a lot of things going in, and I'll show you a schematic of the architecture in a second. So there's two sort of main ideas about a react pattern or a reflection pattern. So you can think of a simple flow chart where you have something kicks it off. So you can think about sensing. So sensing might be a prompt. It might be a question if you're talking to the AI. It might be a monitoring device that captures a trigger. Then you get into some kind of thought. So like, what do I do with this question? What do I do with this prompt? What do I do with this trigger? And I'll show you this again in a schematic in a second. And then you have action. And then you have sort of observation of what's the right thing to do. But ultimately, then you execute. And reflection, self-correction is the idea that it kind of learns from its mistakes. So it learns from what it's been doing, and it learns how to be better the next time. And one of the issues with these Moltbots is because there's now so many of them, and they're communicating with each other on Reddit, you have a lot of learning going on between these agents. So that's another example of self-correction between agents, as well as agents self-correcting themselves based on their experience. So as you can see here, the agent can write, if you think about this like working memory in the brain, it would make a note to itself about what it learned and what to do next time. So I'll talk a little bit about orchestration next. And this is the idea that you have multiple agents in a loop, and you can have hierarchies. So you can have an agent kind of managing the action of other agents, and you can have a workflow with agent activity. And so the more complex the task, you'd have a more complex architecture. For those of you who've been doing business process re-engineering in the past, or object-oriented programming back in the day, or looking at new architectures, you'd be familiar with these ideas. It's like mapping out work into logical units, and then the agents do the work, and then you might have a supervising agent managing all the work that's going on. And actually, I mentioned there was some news this morning on Reddit. They discovered the Moltbots had created a CEO agent for themselves. So in other words, you've got these 1.3, probably even much greater now, Moltbots running around on people's PCs, decided they needed someone to manage themselves. So the idea you could have a CEO agent managing all these agents would be an example of the agents themselves deciding on orchestration. So we're in this moment in time, and I know it sounds science fiction, but we've now got agents running around on our PCs, organizing themselves into groups, creating their own language, appointing someone to manage them, creating their own currency. That actually was in today's news as well, about how they're creating a currency. And so I think we're at an important inflection point as humans where we have to decide whether we're going to manage these agents or whether we end up working for them in the future. So we're getting into some of the technology here now, where you talk about different aspects, and I'm not going to go, we'll talk about this in more detail next week, because we'll get more technical next week when we start looking at building them. but I want to get into the diagram I mentioned before. So a key part of an agent is this idea of how do I remember information, or how do I have access to context information? So there's a thing called RAG, which we looked at a while ago in our previous smart prompting. Actually, we looked at it in AI Demystified about how you retrieve data for the AI, for the LLM, or in this case for the agent. And then you have this idea of a vector database. So when we looked at context windows and we looked at how neural networks worked, we saw how you take English language, gets broken down into bit streams, ones and zeros. That gets broken down into words, 8-bit bytes. That becomes symbols, and then symbols, you create multiple new symbols. And then you have different ways of aggregating the data. So think of vector databases in this context. So a vector database doesn't look like English, but it's encoding of information that the agent needs. And so these are some of the products that people are using, Pinecone, Qdrant, and so on. But essentially, it's if you were to look, it's not like a SQL table where you can inject a record. This is completely unrecognizable to humans and built by the models and built by the math, essentially, for the efficiency of these agents. So when an agent is operating and it queries the vector database, it's essentially a RAG call to the database, and then it brings that back to the agent. And then you have the other side. This will become clear in a minute when I show you how this all works together. You have the APIs and the MCP, which is the protocol that has been developed in these LLMs for connecting to each other and to external devices. So for those of you familiar with kind of plug and play technologies and protocol technologies over the years, it's just standardizing the way AIs talk to each other and agents talk to each other. And then the final thing is this MLC idea. So this is how they optimize the agents to run most efficiently on the LLMs. And they use the term NPUs. You're familiar with GPUs and CPUs. So these are kind of components. You can think of them almost like machines running on an operating system, for those of you who know what I'm talking about with machines. Virtual machines, you might remember that idea. So the same idea with AI, is just that they're in the context of the LLMs. And it's about efficiency, and it's about basically protecting data as well, privacy. So this is kind of the overview, and we look at it schematically next. So somebody either submits a query or speaks to the agent, or as I mentioned, the agent could be triggered on a signal. Then you have this kind of the agent looking for information, looking for context, deciding what to do, and then generating a response. And the response doesn't necessarily mean a response to the prompt. It could be a response to do the work, like canceling the reservation at the restaurant, like summarizing your emails and sending you the most important emails. So the work definition of the agent is created by you if you're creating the agent. So this is something we'll look at next week, creating agents and what do I want the agent to do. So this is the diagram that I mentioned. So the idea is that you have some kind of interface, whether it's a natural language, whether it's a query, or it's a prompt. And the first thing that does is it goes into the agent. And you can think of the agent now as sort of thinking about, okay, what do I do with this input? So it needs to understand the context. It needs to decide on what tools to use. So the next thing it'll do is it'll go to the MLC piece using these protocols to get clarification on what the signal meant, what the question meant. And it has all this logic built into, and this is the learning part. This gets smarter and smarter over time. So it comes back with labels, and then they go into the RAG system, they go into the vector database to say, okay, based on this query, this is what I need to get out of the memory, about my knowledge. And ultimately that'll come back to the agent. I'm going a very high level here. And then ultimately it'll do the interaction to, so as I mentioned, it might be book a travel uh, ticket. I want to fly to Milan, book a reservation in a restaurant, cancel a reservation in a restaurant. It also might be going into, as we talked about in research, so go into the research records in a company and give me back all the data you can find on this particular issue. So whatever the agent is assigned to do and whatever external services, whether they're within a company or they're on the internet, this is what's happening in the AI and tools piece. And then you get results back from that. And ultimately, then you finish with a final output. So the final output could be an answer to, you saw earlier, look at all this data and give me an action plan for an email. So it could be coming back to you and giving you some information after doing a lot of research, or it could actually be acting on something based on a trigger. So that's essentially the overview. And as we go through the month, we'll probably come back to this more often than not. And as we start to build agents, we can look at this again and talk about where we are in the building of agents. And I'll just finish with some simple real world cases. So this would be an example, what they call Jarvis from the Iron Man movies. You have your personal assistant agent. So book me a Tokyo trip, sync my preferences, and clear my calendar conflicts. So that would be a complex command to the agent. And then it would use everything we saw before here to execute that request. And so it's very critical when you create these agents that you understand what it needs access to. And this is why Moltbots are so scary, because they come down onto your PC. And if you're not sure how to manage data on your PC, or if you're not even aware of what the Moltbot is doing, you can get into a lot of trouble. Because it'll do things you didn't ask it to do. So anyway, so maybe we look at doing something like this next week, or I did one this week just for fun. I said, go into my download folder and organize all my download folders into categories and show me what's most used, what's connected, what's a duplicate. So that you can use them for anything you like. And so it's up to you to create the agent that's personalized for your use. But then when you do, you need to make sure that you're managing the security that it needs. And then for programmers, this would be, automating software engineering. So this would be an example of multi-agent. So you'd have an architecture agent, you'd have a coding agent, you'd have a security agent, and then you'd have these pull request agents. So this would be an example. And for people who are experienced with vibe coding, and as we've been seeing over the last number of weeks, how coding is shifting to less, if you like, simple coding into more expert coding, and where the AI does most of the coding for you. This would be an example of something like that. Obvious questions. We've talked a little bit about guardrails. This is a Python example. So if you're a coder and you understand coding, you can actually see the code that it's going to run, and you can look for problems and look for things that it missed. And with the interactive coding tools like Vibe, for example, you can iterate back and just make sure everything is going to work before you release it into production. But more generally, you have things to think about, like how do you protect the agent from getting stuck in an infinite loop? How do you protect the agent from hallucinating? How do you make sure there's a human in the loop for your agent if that's what you want? And then you have the whole idea of access controls, which is a huge topic. I know my friend Valine, who's here, would have a lot to say about this, but governance and permissions and how do you protect, you can think about prompt injections, which Valine talked about last week. You can think about getting hijacked. You can think about also corruption of data, injecting into your data, extracting out of your data that you didn't give permission for. So there's an awful lot to protect and worry about. So just as an introduction, the summary here is that we're in the world of agentic agents right now. It happened as a shock to many people last weekend when these Moltbots came out. Looking at companies, they were talking last year about agentic AI, but most companies reported that they didn't see the benefit. And right now we're seeing agentic AI in the wild, if you'll allow that expression, where they're literally on PCs everywhere. Um, so the question is, how are we going to make sure that we can manage that? And then the idea is that coders are no longer coders, they're more agent architects. So as I said, next week we look at how to create agents. So I've been working on that this week, and I'll do some more next week. There are a number of tools out there. You can do it on your LLM of choice. For example, I did some work this morning on Claude, and I had Claude create an agent for me. But before I executed it, I saw how dangerous it was. And I said, let's not do that yet, because I saw all of this deletion stuff it was going to do, and it was confusing. It talked about deleting files, and then it talked about generating a report of the files, but don't delete. So that was an ambiguity in the code that Claude had created. So, but then so you can do it on the LLMs, not just on Claude, but on ChatGPT. I did it with ChatGPT this week, and it started creating Python code, and I got into a terminal on my computer, and I got lost very, very quickly. So there's complicated ways to build agents, or there's smart ways to build agents, and there's toolkits. So we look at some of these next week, and maybe we'll pick one, and I'll try to find one that's either free to use on the LLMs or inexpensive to use as a tool, and we'll create some stuff, and then I let you all. We'll take direction from everybody as to where we want to go next. All right, so I'm going to stop.